Hello, I'm Heather Dewey-Hagborg. I'm a visual artist and a PhD student at Rensselaer Polytechnic Institute in upstate New York. And I'll be talking to you today about kind of an emerging body of work that I've been putting together for the past couple years around this idea of genetic insecurities. So ways in which our genetic information is insecure and ways in which perhaps we're insecure about the ways in which our genetic information is interpreted. So genetic monitoring or surveillance has been the stuff of science fiction for years. But today, with the increasing accessibility of biotech through do-it-yourself biotechnology, through the proliferation of community biolabs, and through the decreasing costs of biotechnology as well, it's becoming a reality. So in this new future, in this new reality, where the very things that make us human become a liability. So we constantly face the possibility of shedding these things in public, hair and skin and saliva, leaving artifacts which anyone could come along and mine for information. In my art project, Stranger Visions, I'm confronting this emerging possibility of genetic surveillance by collecting forensic samples that strangers leave in public space. I extract DNA from these samples and attempt to find out as much as I can about what these people may look like. And then I attempt to represent this in the form of a three-dimensional portrait sculpture with photorealistic qualities. I present the sculptures along with the original artifact that they're collected from, in this case a cigarette butt, and photographic documentation of where I found the sample, along with the details of the genetic profile that I've created about this person from what they've left behind. So this is what I exhibit. And I'm going to show you a short video that kind of documents this process, which I'll narrate to you. So the first step here, of course, is actually finding samples. And I'm looking for things that are fresh, so I'm not going to go digging around in your couch cushions or digging through the trash. So cigarette butts and hair, bits and pieces of people's fingernails, chewing gum, all are good samples. Nothing that's been stepped on or rained on. And I take these into GenSpace, which is a community biological laboratory I work at in downtown Brooklyn. And actually, I learned everything I know about biotechnology through GenSpace. I signed up and took a crash course, and they taught me how to extract DNA, how to amplify it using a technique called polymerase chain reaction, or PCR, and how to examine that reaction for specific traits. So I take the sample and I cut it into lots of little pieces, and then I follow a protocol which is just a lot like following a recipe. So it's a matter of adding the right chemicals at the right times, shaking it up, heating it, cooling it, centrifuging it. And at the end of that process, hopefully I come out with purified DNA. And I use this polymerase chain reaction technique to amplify these little sections of the DNA that code for traits. So things like whether you have a tendency to be overweight, whether you have a tendency to have a bigger nose or a smaller nose, what color your eyes are, whether your skin is darker or paler. And then using gel electrophoresis, I can tell if I successfully amplified that trait or not. So in this case, I have two samples that I've successfully amplified here. And I'll take the result of that reaction and I send it to a company for sequencing. And they send me back essentially these text files that are filled with A, T, C's, and G's, the base pairs of DNA. And I can feed these into software I've been developing, which will parameterize or morph a 3D model of a face based on these characteristics. And I'm building this all off of open source code or published research. model and I send it to a 3D printer where it gets printed in full color. And that's what I exhibit. And you can see that the faces that come out of this are very detailed and compelling. They have a real quality of an actual face to them. But if you look closely, you can see that there's still these digital artifacts, which is something I'm interested in aesthetically also. This is one of my favorite portraits. So the first question I usually get about this work is about accuracy. And this is my self-portrait, so you can make up your mind for yourself as to how accurate you think it is. From my perspective, there's a lot of things we have in common, and there's also a lot of differences. It's kind of like a family resemblance or a general likeness. But the point of this project isn't about accuracy. It's meant to be a provocation in the spirit of tactical media. It's meant to call attention to questions of privacy and genetics and our biotechnological future. So the point here isn't that I know everything about you from a piece of chewing gum that you leave on the street, but that I, as this amateur who signed up for this one class, can know as much about you as I do, and I can potentially find out a whole lot more. This is Kary Mullis. He won a Nobel Prize for the invention of polymerase chain reaction, which is the technique that I'm using in Stranger Visions. And in 1995, he was joking about creating a company called DNA Anonymous. And the company would have essentially one product, which would be amplified solutions of DNA that they would sell that you could then use, you could spritz it on yourself anytime you wanted to be anonymous in terms of your DNA. Now, Mullis was joking when he talked about creating this company, but at the same time he predicted that in the next 10 years, someone would actually do this. So that was 1995. Not quite 10 years, but in 2009, a group of scientists in Israel proved that you could actually fabricate evidence. And so they created, essentially using the techniques that I'm using, they created fabricated evidence, the kind of which you'd find at a crime scene. And using the current protocols and techniques that the police use today, it was indistinguishable from actual evidence. So in a project I'm working on right now, which is a collaborative piece, DNA spoofing, we're taking kind of a playful approach to thinking about this fabrication of evidence or the creation of DNA. techniques or ways that friends could help each other out if they want to be a little more DNA anonymous. Now, the DNA spoofing project is meant to be humorous, and Stranger Visions is meant to be provocative. But the issues behind these works are real. So to fabricate evidence, the kind of what you'd find at a crime scene, requires little more than the tool set I'm using in Stranger Visions, so DNA extraction, amplification, purification. And these are the same techniques that you or anyone could use to analyze the DNA profile of your friend or your neighbor or your child. So this is becoming a reality. And the question this raises for me today, I think, is if I can do this, someone with relatively few resources, access to a community biological laboratory, and not very much funding, what could a corporation or a government with so many more resources and so much more money be doing with the same information or better information right now? And to conclude, in the past couple weeks, it's become increasingly apparent that the information of millions of Americans is being constantly monitored. Now, if the NSA can ask for our phone records, what's to stop them from asking 23andMe, a personal genetic profiling service, for our genetic information? You can see here, in the terms of service, they make it very clear that they'll offer up our information if asked. So as more and more of us are voluntarily profiled, I wonder, and my question for you is, are we simply inviting the most intimate breach of privacy imaginable? And if so, what can we do about it? Thank you.